Good afternoon, everyone. Welcome to our reimagined Open House 2020. My name is Justine Dowden. I'm a project coordinator for the Geo-Referenced Infrastructure and Demographic Data for Development program, also called Grid 3, which is within the Center for International Earth Science Information Network, also called CIESIN. I lead Grid 3's work in South Sudan, Namibia, Burkina Faso, and Mauritius, which includes COVID-19 response, census support, and capacity strengthening in GIS, Geographic Information Systems. Each year, we're so excited to open our campus to the surrounding community to share our extraordinary research and our love for our amazing planet. So much has changed, of course, about the way we interact these days. Lamont has needed to shift our in-person events and programming into an online format. These digital panels have allowed us to continue to meet with core community where they live while expanding our reach into the rest of the United States and the world, engaging far more people than we ever would have in person. Lamont's Open House is, in many ways, a celebration of our science and our extraordinary planet. We hope this event will ignite a deep and abiding love for and interest in Earth and climate sciences. Our many lectures offer an opportunity to hear directly from our scientists about their most current explorations and discoveries. This year's list includes a vast range of subjects, from the cutting-edge science of carbon capture to the work of understanding our changing coastlines and the risks of sea level rise, to our efforts to proactively cultivate a more diverse and inclusive scientific community, to the missing research so urgently needed to better understand when and why volcanoes erupt. This afternoon, you will hear from Dr. Angel Munoz and Emily Schnarr on our panel titled Fighting Disease with Geospatial Data and Climate Prediction. The speakers will introduce their work, and a Q&A session will follow, both with me as your moderator and with the audience. Let me start by introducing Dr. Angel G. Munoz, who is an associate research scientist in the climate program of the International Research Institute, focusing on climate variations and predictability. His current work focuses on better understanding climate variations at multiple timescales to enhance prediction methods and climate models, and to co-develop climate services with institutes around the world to improve food security and health decision-making processes. He has a PhD in climate sciences from Columbia University Department of Earth and Environmental Sciences. Dr. Munoz, please go ahead and tell us more about your work.
Hi everyone. Yeah, thank you so much for the opportunity of being here another year. I've been participating in this event since I was a PhD student at Columbia, part of the Lamont-Doherty Institute. So it's a great pleasure to be here telling you a little bit of this amazing work that we are doing at the International Research Institute for Climate and Society. This is an institute, as you can see from the name. We translate state-of-the-art science, and in this case, you're going to see both monitoring and climate predictions in a way that we can actually try to address very important diseases that impact society. In particular, the kind of work that I have been leading with a big team, a lot of people behind it, is related to what we call Aedes-borne diseases or mosquito-borne diseases. In particular, these mosquitoes that are related to these diseases like Zika, dengue, and chikungunya. And probably a few of you already know that we have an ongoing dengue epidemic in several parts of the world, in particular in Central America. So why are we doing this? We do know that these are important diseases, and a few years back, probably you remember that we had the Zika epidemic. And today we have, obviously, everyone, and we will talk about that a little bit too, COVID. But an important thing is that more than 50 million infections of these mosquito-borne diseases, like dengue, again, chikungunya, and Zika, are happening worldwide every year. And something extremely urgent for us is that we have been observing an increase of 30-fold during the last 50 years. So can we actually say and do something about that? And the answer is yes. We have been actually partnering with a lot of institutes, a lot of experts, from the decision makers on the ground to the, as myself, climate scientists that are working, like at Columbia University, but also in Central America, North and South America, and the Caribbean, to be able to answer, to be able to provide concrete information to make decisions. And hopefully I will be able to tell you a little bit more about that during, like the conversation they're going to have next. But in brief, our system called CIESIN is a system that can help decision makers in the public health sector, but also each one of you, like the family as a decision-making unit, what to do, where to go, even if you want to consider going to a particular place in the Caribbean, once we can travel again, for tourism. Or if I am in Florida, where are the places where I expect to have the environmental conditions that are more suitable to have any of these diseases because are being transmitted by mosquitoes that are sensitive to climate? What is the overall impact of climate change and natural climate variability on all these diseases? That's exactly what we want to do. And I hopefully will be able to show you later like this amazing system that we have developed with the funding of NOAA and several other institutes for you, for all society. Thank you.
Thank you very much. Excited to hear more. Next, we have Emily Schnarr. So Emily Schnarr is a senior staff associate at CIESIN. She is a country manager for Nigeria for CIESIN's Grid 3 program, where she coordinates government stakeholders in the provision and use of high-resolution geospatial data to improve decision-making within various sectors. She has a master's degree in climate and society and environmental engineering, both from Columbia University. Emily, go ahead and tell us more about your work.
Thank you, Justine, and thank you everyone for joining today. As Justine already mentioned, my name is Emily Schnarr, and I work at the Center for International Earth Science Information Network, which is a unit of the Earth Institute at Columbia University. Currently, I serve as a project manager for an Africa-wide project called Grid 3, and that stands for Geo-Referenced Infrastructure and Demographic Data for Development. I have to say this is the most impactful and most interesting project that I've worked on at CIESIN. I've been working at CIESIN for 8 years, and that's not to say anything about the previous projects that I've worked on. It really demonstrates the impact and the significance of the project that I'm currently working on. It's funded by the Bill and Melinda Gates Foundation and the UK Department for International Development. We work with government agencies, and I'm focused in Nigeria, and we work with government agencies on the provision, production, and use of high-resolution geospatial data for the country. And so in Nigeria, what that means is that we help to produce, in coordination with government stakeholders and other types of stakeholders in the country, to develop accurate and precise geospatial data, which is essentially data that has geo-coordinates and the latitude and longitude associated with it. And in places like Nigeria, that's particularly important because their last census took place in 2006. So outdated population is a problem for the current state of things. In order to determine where you want to allocate health resources or schools, you really need accurate numbers in terms of the number of people that live in an area and where they're located. So we work on the production of that, and then we also help to develop data on boundaries, as well as infrastructure and settlements. And so all of this data is very useful for a multitude of sectors, and we really work closely with the governments in the countries that we work with to ensure that the data is adopted, and we're not just providing this data and it doesn't get put to use. Like, our ultimate goal is that all of this data is really demand driven, and it's openly available to the public as well. And so that's another significant component of the project, is that this data is free to the public, and there's a lot of other stakeholders as well that are now using this data. So I'll talk a little bit more about it during the question session. Thank you.
Thank you very much. So we'll start with a few questions for Angel. The first is, can you give us a real-world example from your work of how using past environmental information and climate predictions have helped you understand how to predict future disease outbreaks?
So this is a system that we call CIESIN, and the name is not only referencing the mosquitoes, but it's also more or less the acronym, the name for environmental suitability. It's a system to see if we have the environmental conditions that are suitable to transmit these particular diseases that I was mentioning before. And the story goes back to, if you want, 2016. We were in the middle of the Zika epidemic, and PAHO, the Pan American Health Organization, and WHO, the World Health Organization, contacted the IRI, our institute, to see if we could help them not only try to identify ways to transfer the risk associated with the diseases, but also to try to forecast that. And as you can probably imagine, that is not very easy. If it's already complicated to forecast the climate, imagine forecasting something as complicated as disease. So what we found is that we were good at forecasting the conditions, environmental conditions that are suitable for the transmission itself. It's far more complicated to forecast exactly in one particular place how many cases of chikungunya or dengue or Zika we're gonna have. So we have been created, well, this is a long evolution since 2016, but this particular system was launched in January, right before the entire COVID thing impacted all of us, and can help us identify what is the typical behavior every year for the particular disease of interest. Remember, that are related to these mosquitoes that transmit, for example, dengue. And in these colors in red, you find, let's say, an assessment of the potential risk of transmission. You can see that in the Yucatan Peninsula, in Mexico, you might have a higher risk than in a few other places. And we are building these particular map rooms or tools using the information, co-designing from the very beginning with these professionals in different institutes, the people who are actually making decisions with this kind of tools. So I can talk a lot more about how we actually use it, but I might be like out of time right now. But just so you know, this is a publicly available set of tools that we are happy to share with you. And there are, like, if you are more interested in the details, the technical details, we have the technical publications about that. Thank you so much.
Yeah, thank you. Definitely check that out. So what led you in the direction of developing climate prediction systems that can support public health? Has there been anything that surprised you or changed your thinking along the way?
Yeah. That's a very good question. So in this case, as I just mentioned, the decision makers, the end user, these people that are working in the World Health Organization to help us all, contacted us in order to join forces and to try to have a very strong, robust interdisciplinary team to help create this software, these tools, these what we call climate services or climate and health services for society that we have right now. So it has been inspiring to see how, starting with a concrete demand of the kind of progress that they wanted, we have been navigating together this journey in order to have that kind of, like final outcome that I was just mentioning a few seconds ago. We haven't need, in this particular case, we didn't need to change the topic. Every time you are doing some research, something new happens, you discover something new, and you want to go perhaps, or you need to go in a different direction. We didn't need to do that in this case, because we have been having this continuously updating, flow of information with our partners. That again involves like medical doctors, people that are working on the field on, should I do vector control? That's the fancy word for killing mosquitoes so we don't get sick. Now or then? It's gonna rain, and it's gonna rain now or then, because if it rains and I'm gonna use my chemicals to kill the mosquitoes, then the rain is gonna clean everything. So because we have been having that continuous interaction with the decision makers, we have been lucky enough as to keep like moving forward in the original direction that we wanted. At least in this case, that was, has been an amazing experience from years and years.
That's great. So how can the system be applied to situations like fighting the spread of COVID or are there other applications?
Yeah, that's another amazing question, because actually, when we were creating this tool, obviously we didn't know about COVID. It was basically done in mid-2019. You know, we decided to launch in December, January 2020, and then COVID happened. And you know what we learned from our partners at PAHO, the Pan American Health Organization? They said, hey, take a look at this. COVID is enhancing, it's increasing the population's vulnerability. You know, for example, in Central America, that's everywhere, but I'm going to talk right now about Central America that we have here in the map. In Central America, it's impacting because people cannot go to the fields, it's increasing food insecurity. There are a lot more people that are, like, if you want, starving, especially, for example, in the so-called dry corridor. So you have people that are confined at home, don't have enough money, overall the vulnerability has increased. And then you have an ongoing dengue epidemic, the worst on record, actually. It started in 2019, and we still have it right now in 2020. And you have what we call a compound effect. We have dengue happening at the same time that this COVID pandemic, and these kind of maps are right now helping people in the Pan American Health Organization, our partners who have been, as I said before, co-developing this system from day one. They say, oh, this place that is like more red than this other one that is like green might require more resources. That means more people, more of our staff, more money from the different institutes need to go there so we can do our job and try to save more lives. So it's so interesting how COVID has changed everything we do, but it's also interesting to see that because Mother Nature has so many links to so many subsystems, so many of these like different diseases, our system that was originally designed only to address mosquito-borne diseases like dengue can now be used to analyze this compounding effect with COVID.
Wow, okay. Lots of different applications. So you're providing the tools and information to help public health officials make relevant, informed decisions, like you were just talking about, this more targeted approach. So how do you ensure that in-country stakeholders are actually using those tools and information to implement the life-saving measures?
Yeah, thank you. Another great question. So
in other words, how do you turn research into practice?
Exactly, yeah. So that's a very unique feature that we have at the IRI, at our institute, but also in Columbia University at the Earth Institute. We want our science not to be just some fancy maps and some equations that we are working on. We want that to be really translated so it's useful for society. So in a lot of other universities and places, like state-of-the-art places, you see a more traditional approach in which the scientists think about a particular problem and then finds a solution and provides that to society. That is awesome. We have a different approach in which from day one, we sit with the decision makers, as I explained before, and we co-identify what are the problems and what are feasible solutions. Sometimes we want perfect solutions and those solutions cannot be achieved. So we sit with them and together we create through that continuous conversation from day one or day zero, if you want, or day -10, the approach is co-developed with them. And I think that that is the key to success in not only this project, but in a lot of projects that we have at the IRI and the Earth Institute.
So based on those conversations, have you had to shift your work in any way?
In this case, as I said before, we have been very lucky because of the continuous conversation, we have been on track. Because sometimes if you just try to develop this system based on your knowledge of the climate in this particular location, you might, sometimes you might go in one particular direction, but because we have continuous conversations with the decision makers, we just have small corrections as needed in order to keep advancing basically in the same direction in this project. So I think that this is, as I just said, a key for the success of the kind of, as you said, research to operations or research translated so it's useful for society kind of work.
I see. Okay. So last question for you, at least for me, is we know that weather patterns are becoming more volatile than ever before. So how does your system keep up with these changing patterns?
Yeah, that's another great question. So probably we all know that climate varies at multiple timescales. So it's not like if I want to forecast, if I want to forecast what's going to happen in the next 2 days, that has nothing to do with what we call a background signal of what has been happening. So the system that we have created is actually designed to take into consideration from the very beginning all these different timescales. So what you can see here is that climate varies at weather timescale, if you want daily, or subseasonal, which is, let's say, 2 to 4 weeks. Then seasonal timescales, decadal timescale, 5 to 10 years, and then multi-decadal and longer timescales that involve climate change. But climate is not only climate change or only one of these particular climate change timescales. It's a continuum that ranges through all these different timescales, and the system is designed with the decision makers to pay attention to what is the predictive capacity or predictive skill that we have at all these timescales. So we are including the effect of climate change from the very beginning, but also of the different variations that we might see at the multiple timescales, because we all make decisions at multiple timescales.
Well, this has been really interesting to learn more. That's great. Thank you so much.
Thank you.
So I have a few questions for Emily as well. So Emily, how do you effectively communicate the potential use and power of geospatial data to stakeholders who may be unfamiliar with that type of data?
Sure, I think it's really important, as all scientists know, to communicate science in an effective way, in a way in which the audience understands, what you're saying. Geospatial data is quite simple. It's data that has a latitude and longitude associated with it. We use Google Maps all the time. It's pretty obvious when stakeholders see our maps that they're very beneficial. So as an example, I'm talking about data, geospatial data right now. If I were to show you a map, you could really see what exactly I'm talking about, and it's a lot easier to understand. So this is a map of population, or actual population data in Lagos State. And as you can see, it's a very detailed, it's what we call high resolution. The scale is at 100 by 100 meters. And the circle, as you can see within Lagos, if you zoom into that circle and take away the population data, this is satellite imagery of that area. You can see there's a settlement there. There's parts that are less populated than others. And then overlaying our population data, you'll see the level of detail, and that it does coincide with the settlement area and with the areas that look more populated. So this is just an example of how we show the data. Sometimes we also speak with targeted stakeholders within the health agency, for example, and we demonstrate how the data can be used within the health sector and for their purposes and what their goals are. And so in Nigeria, for example, polio has been a really difficult disease to eradicate for many decades, and it was eradicated just this year, and that was an enormous accomplishment. And so our data was actually utilized for those campaigns, and it helped to, we can actually say that it helped to eradicate polio in Nigeria. And the way in which it was used was through initial demonstration of maps and demonstration of the power of geospatial data, essentially.
Great accomplishment. So on the subject of vaccines, what does a microplan mean? And what do digitized maps make possible that could otherwise not be achieved with hand-drawn maps?
Okay, I will read a definition of microplanning because it's complicated, but in Nigeria, it's straightforward. So microplanning is a broad term that refers to tools that health workers use to ensure that immunization services reach every community. It's used to identify priority communities, address barriers, and develop work plans with solutions. In Nigeria, we refer to microplan maps, which are, initially they were hand-drawn. So you can Imagine it was a paper-based map with a ward, for example, like a county or a state, but in Nigeria, a small administrative unit is called a ward. You have the settlements located, and then the population numbers within that settlement that need to be, the number of children essentially that need to be vaccinated. And in Nigeria, they've been digitized. So it's a computerized system that produces these maps now. And through geospatial data, you can easily calculate the number of people within a settlement and the number of people that need to be vaccinated. So it's really improved the efficiency and accuracy of the microplanning process because you're able to produce a bunch of maps quickly with accurate population numbers. Otherwise, it's like, it would be guesswork. The paper-based maps were based on older data that wasn't necessarily as accurate or as precise as what we've provided through Grid 3.
So you can really make that field work more precise. Interesting. Okay. So what are some of the cultural challenges in bringing such a large project to a different culture? We know that countries in Africa have, unfortunately, a long history of being dictated to by the West. So how do you broach that sensitivity? How do you thoughtfully collaborate with the in-country stakeholders? And is there anything you're doing differently now that you've learned along the way?
Thanks, Justine. That's a good question. It's a tough one to answer, but it shouldn't be. I think we should talk about these things explicitly and to first be aware that that is a sensitivity, that there's history and a lot of things that have happened in the past for, you know, that may result in biases. And I try to be as aware as possible of like how I'm coming across of these biases so that I don't act on them. You know, so that I, like in most situations, I can avoid acting on those biases. And the way that the project is structured, there's guidelines that really that enable for you know, for this to be for Nigeria essentially to take this on as their own project. So we hand over almost all of the control to the country, and they are the ones that are in charge of it. I'm the only one in New York that's really working on this project. Everyone else is in Nigeria. It's totally government operated at this point, essentially. So what I do is now I really listen. I take a back seat during meetings. You know, I try to learn as much as possible about Nigeria, even after working for 2.5 years in the country, not directly in the country, but you know, on the project, I still don't know nearly enough. And so I think just listening and letting the country and the government and the stakeholders and our team there guide the project helps with that.
Yeah, I can see that. So on a similar note, so precisely identifying people, locations can be a double-edged sword. And highly precise location data can bring privacy concerns to the fore. So how does Grid 3 ensure the security of these data, that the data won't be misused? And can you give us some examples?
Sure. You know, having precise population data and having open data that where you can see where people in settlements are located, for example, along border areas, or as we know in northern Nigeria, there's a lot of security issues. That's a risk. There's a risk that it can be used for nefarious purposes, that those areas may be targeted for violence or you know, other bad reasons. So what we do is we see that the benefit of having this data openly available far outweighs the potential for that risk. And we work very closely with a lot of stakeholders to ensure that the data is used for beneficial purposes. And that's really the most that we can do, is to promote its effective and good use. And I think that, you know, from what I know so far, it has not been used for any malintent.
Great. So last question just for you is that Oh, so a primary goal of Grid 3 is to ensure long-term geospatial data production and use by decision makers in the country. So what components of the project do you see contributing most to this goal, sustainability?
Thanks. Well, we work with and country stakeholders and for capacity building purposes. We do a lot of trainings to ensure that the data is well understood and that it's utilized and incorporated into decision making. So once you have a data set like our population data that's used for polio eradication, the value of that is obviously recognized and it continues to be used. So the more we promote and integrate the data into government decision making and government processes, the more it'll be used in the future. Capacity building is a huge part of that. You know, having people within the government agencies able to work with the data, producing it on their own and managing it is a huge part of the project as well.
Thank you. So I have a question for both of the panelists. So why do you do what you do? What motivates your science?
Emily, you want to go first?
Sure. I think, you know, when you see the impact of your work and you see the difference that it's making for society and the relevance of it. So our data was used for COVID-19, and it was awesome to be working with the Nigerian government on COVID-19 efforts and seeing the effectiveness of the data for that, seeing the application of the data for so many things, and to be involved in a project that has such potential impact for, you know, helping people who are in need. It's also really inspiring to see people who like Nigerians are just very tech oriented from my experience, and it's awesome that you know, they take on the data so quickly, and they are, you know, like just very motivated. And I just feel very fortunate to be working with a government that's also motivated, because that can often be difficult. So it's very motivating for a multitude of reasons.
Yeah, I totally agree. Totally. In my case, I don't know, I'm going to make a long story very short. I originally was a theoretical physicist. I was trying to, you know, study black holes and galaxies and neutron stars and all kind of, you know, super cool stuff. But at some point, I just realized that all that knowledge and all that, you know, power that science provides to humanity should go back to society in a concrete way in our planet. So I fell in love with the way actually IRI and the Earth Institute, Columbia University do stuff. And I try to apply, you know, what they taught me in terms of, you know, complex math and physics and, you know, how to handle observation and statistics to help society, which is actually the mission of the IRI. So this is a concrete example here in terms of health and climate services, you know, how we generate, translate, transfer, and use this climate, environmental, and health information. But there are a lot of other things. It's not only me, I think that we all at the IRI, we do this because we feel passionate about it, and because we believe we can help with these tools and with the state-of-the-art science to make a better world. So I don't know, I'm gonna say a short answer is because we love it and we feel passionate about it, and because we are, you know, lucky enough as to get the support from Columbia University and a lot of donors outside of Columbia University to be able to do it.
That's wonderful to hear. So I'll ask you one last question, again, to both of the panelists. What would you like the audience to take away? What do you most want them to understand about your work? Angel, go ahead.
Okay, yeah, I can see that now you're balancing things. So I think that beyond, you know, I can say a couple of things in terms of this particular system, the CIESIN system, but I think that the most important takeaway to all of you at all ages, but especially the next generation of scientists that we're going to have in the world, to be fair, to be, you know, just love what you do, And we are here really to make a better place for all of us. And we can see that the importance of that, not only because of COVID, but COVID is a good reminder to all of us to love what we do and to try to make a better world. I think that that's the most important thing, independently of how you do it. If this is like through these map rooms that I was showing that we have created, like, you know, as a team with not only Columbia University people, but outside of Columbia University people, just do what you love for the benefit of everyone. I think that's the most important. I think a bit too poetic, but important nonetheless, especially these days we can see it. Thank you.
Never too poetic. So Emily, what would your takeaways be?
Similar to what Angel said, like I can't really top that, but just that evidence-based decision-making is really important. Using science to help society to solve complex problems is possible, and it's the right way to do things. And you see the effectiveness when you're using data, and good data and sound statistical methods. You know, in Nigeria, and no matter where you're working, if you're using good data and a solid scientific foundation, you're able to solve really interesting and necessary problems. And I think that's pervasive in any science. And yeah, just to, you know, like in terms of having an impact, I think, you know, passion is definitely what's needed, and seeing people benefit from what you're doing and seeing the impact that it's having on the environment is also key. And I think we all work to do that together.
Absolutely. Well said. So I see that we're getting a few questions from the audience. Thank you very much for submitting those. I'll be reading a few of those out. So we can, switching off here, I'll address this to Angel. How are the map rooms and geospatial tools you're creating applied to other sectors or other public health issues? So you mentioned food security as an example.
Yeah, correct. So let me go back here very quickly. So this is again our map room. And as I showed before, we just select on any particular location, and we get an updated, like real-time updated information on what is the typical behavior, what has been happening so far in this dark line over here, and then the forecast in red. So we can see, well, if this is going to be above normal conditions, if this red line is over here, is actually lower than the usual conditions that we will normally see in November and December. So the approach is completely general, and it's something that we have co-developed with our partners, international and local partners in different countries, through this Columbia World project called Act Today, which is more or less, again, another acronym for Adapting Agriculture to Climate Today for Tomorrow. And the idea here is that the approach is so general that you can use it to forecast something like diseases like this one, but also in terms of food security. For example, some people in our team, I'm collaborating in that project too, are starting to forecast not only rainfall and temperature, things like evapotranspiration that are essential for crops. It's also, now this approach is being used to address something like undernutrition in Guatemala for kids under 5 years old. So, you know, it's not only about how this approach that has been published, I actually have like the recent publication this year in Nature Scientific Reports, it's not only about how can be used for mosquito-borne diseases and some other diseases in the public health sector. It's about how this new way of doing things, can be used in a lot of different contexts. And I think that is part of what we want to do here. So, because nothing is independent of anything else. You know, everything is linked to something else. Thank you.
Right. So Emily, I have a very 2020 question for you, which is, how does working remotely on your project affect how you do your job? Are there any benefits or disadvantages? I know that you usually in any other year would be traveling a lot.
Yeah, I think the travel aspect is the most impacted. Like I was supposed to go to Nigeria in, I don't know, probably for probably a span of like 3 different times by this point. And so that's obviously not happening, and it's disappointing. And the project has definitely been impacted by our team not being able to travel, because we were supposed to have some workshops and some trainings, and the training in person would have, for example, taken 2 weeks, and now it's taking months because it's happening virtually. So those are really significant project impacts that have resulted in us really changing strategies and finding ways to be effective. But despite those things, we've been able to succeed and move forward surprisingly well. And working remotely in terms of the work is okay. I think we really benefit as a team at Columbia from meeting together and seeing each other face to face and talking about things like on an ad hoc basis. So when we're not in a meeting, we often talk about work, and it's just because we're around each other, and we learn new things about what's happening in another country and on the project. So that is a part that I see not taking place as much, but overall it's been okay.
I think we can all relate to this very much so.
Yeah.
So similarly for Angel, how is COVID affected by climate change?
Yeah, that's a very good question. And I think that the short answer is we still do not know that. So it will be responsible for me or probably anyone else to say that there is a direct link between COVID and climate change, because we still don't. Let me just say this: climate is. Imagine that climate is a symphony, and a lot of people in the orchestra are playing. So climate change is one of those instruments, or a group of those instruments. But climate is more general than that, and we still don't understand the precise link between COVID and climate. So we cannot even say about anything concrete about climate change or any of the other factors like instruments that are playing in that symphony that we call climate. So I think that our responsible answer is we do not know yet.
Yeah, I mean, in so many respects, the research is barely catching up. It's so recent, just a matter of months. So I should have asked you as well how the remote work situation is affecting you and your work.
Yeah, well, I totally agree with Emily. I think that she explained, exactly what we are all doing. And I think that, CIESIN and IRI and several other institutes at Columbia University, but CIESIN and IRI are sister institutes that are doing similar work, and we need to travel a lot, especially because we work, as I explained before, with decision makers on the ground. So we are trying to do that now using, different platforms, going virtual and anything, but definitely is not as fast and sometimes not as efficient. Even when you can see the face of people, it's not the same as being there and being able to capture, because you are there, how much they are understanding or not, and then the subtleties of, oh, let's try this different way to say things. At the end of the day, our work is also, it's also teaching and learning from at the same time from everyone, and it's definitely getting slower. But nonetheless, as Emily stated, we are advancing, we're making progress, and it's better to have slow progress than have no progress at all.
Yeah, and sorry, Justine, just to go off of what Angel said, having those in-person interactions really is nothing can replace that. I learned so much when I go there, even in a span of 2 weeks. I learn immensely, and having those personal relationships with the stakeholders, that's key. And without those personal relationships, the project wouldn't happen. Our progress would not be where it is today. So that's definitely missed.
Yeah, that's relatable as well. So a question for both of you that came through is, do you pay for any data, and are there public data sets that you use?
We don't pay for any data directly. obtain it sometimes through relationships that we have with certain data producers. So it can be kind of a complicated network in which we obtain data sets sometimes, but most of our data inputs are open source. Sometimes it's direct field data collection, and that is funded by the project funders. But essentially, you know, it's all open and it's supposed to be public, and we provide it in a public way because we produce it in such a way as well.
Yeah, I totally agree with that. And I'm going to say that because of the kind of work and mission that we have at the IRI is for society, we make extra efforts to have everything open to the people. So everything is open source. Like we really try to, even when we need to publish, when we publish our work, we pay so every single person, especially in developing countries, can read through all the technical details and reproduce the research and the work that we do. In terms of the data, what we normally do is that we actually create new data sets based on, for example, local station data, like weather stations that the countries, the developing countries have, and involve or combine data from satellites that are publicly available. So in some cases, as Emily explained, the donors will help us with some funding to co-produce those data sets. But the short answer is that we work with open source, with open data, and we in general don't pay for any kind of data. You know, it's like when if needed, if it's something like we need this particular satellite data to identify if there is a drought in Africa because of X, Y, and Z, and this is the only source that we have, we might need to pay for that. But in general, in our team, in the team that I lead, that I coordinate, we don't do that. But you know, I can see that might be something that might happen, but not to the best of my knowledge.
A pitch for open data in general, which could be a whole separate panel.
Totally.
So, Angel, do you have any impressions regarding ambient temperature effect on the infection rate of COVID?
Haha, we're coming back to that one, isn't it? Okay, so I'm gonna say that there is a lot, as you all know, the scientific community has been very active about COVID. Not only, I'm gonna say the medical community, but you know, climatologists, a lot of people, environmental scientists have been addressing this topic, and there is still a lot of debate, a lot of analysis and research being conducted addressing this particular question that is related to the climate change linked to COVID. And the thing is that a lot of these, it's not even like in the peer review, that means like it has not been like reviewed by other pairs, by other scientists. So we are still like investigating this, but short answer is that there are a lot of commonalities. I don't know how to say this in a simple way. So it's, you know, not getting technical, but trying to represent the reality. Like I'm gonna say, there are a lot of commonalities with some other diseases, let's say like flu. We know that there is some seasonality in flu. You know, it doesn't happen the same number of cases. You don't see the same number of cases every single month. There is a seasonality. There are some particular seasons when you see the flu. We know that, in particular in New York, where we are right now, we're starting to get those flu shots. And that is controlled by environmental variables like temperature, like environmental temperature, exactly as what you are asking. So there seems to be some, I don't know if I can say consensus yet, but there seems to be the idea in several people in the scientific community that COVID has influence on climate variables like temperature. But again, you know, number one, I am not doing any particular like direct research regarding the link between climate and COVID, so I'm not the authority to talk about that. And I'm gonna say that the short answer is we are still investigating all these details. Most probably there is a correlation, there is a link to temperature, but we still need to figure out those things.
True. So for both of you, how do you recommend people who are interested in interdisciplinary research begin pursuing it?
So this is my experience, and obviously there are so many different ways in this world and universe to do things. But this is my recommendation after being a, like maybe too traditional mathematical physicist. I think that be open-minded, just have, like pay attention to how things are related, because as I said before, and we know, things are intertwined in such a way that sometimes it's very difficult to isolate things. And the traditional approach in science is to try to focus on only this process, sometimes forgetting that it's connected to so many other things. We might say, oh, it's connected to a lot of other things, but in real life, we forget about those things. So the next generation of scientists that we are, training at Columbia University, and that we want to see more and more everywhere in the world, is this kind of person that can speak natural sciences and social sciences. And if I may, at the IRI, we even use the name climate and society scientist. So it's not the traditional mathematician or physicist or climatologist or the person that is an expert in economics or finance, financial tools. It's a person that even when has a specialty and has a focus on a particular set of skills, can speak and can understand to other people, so we can build the bridges. I think that is my recommendation. And again, there are so many ways to do this, but keep an eye open and try to make an effort to learn those other languages, those other sciences. Have a focus, be special on a certain set of skills, but don't close your mind and try to be able to work together, to work with some other people to help society with all these tools.
Thanks. I think similarly to Angel, for my personal experience, my undergrad was in a program called environmental systems. So it wasn't strictly one specific environmental science. It was about how the ocean interacts with the atmosphere, how climate change affects societies. It was really interdisciplinary. And moving on from that, I did another interdisciplinary program called Climate and Society. And I think the interdisciplinary programs are becoming more popular, and we definitely have more of those at Columbia now as well. And the impact, or it's very much recognized that the different sciences and the different groups have to work together in order to solve these complex problems. So it's quite easy, I think, now to work on projects that involve a lot of different sciences, and I think also, to be open-minded about what you're working on. Like my background was in climate change, and now I'm working on a project that's not directly related to climate change, but it's still about like data and helping people. So I think just having an open mind on what you're working on is really helpful, because you may have a specific idea of what you want to do, and then you find out that working on something else is just as meaningful and enjoyable.
Life happens and you just make these turns, yeah. So what qualities make for a successful and happy scientist?
Passion. Feel passionate about what you guys do. That helps, because science, and as every other field that we do, we humans pay attention to, nothing is especially difficult, but nothing is especially easy. So passion will help you. It's the fuel to help you to navigate several of these things, and find a place where you can do what you love the way is needed. Identify what are the problems, the real problems out there. If you really want to, it depends on what you want to do. You can feel passionate and feel free. Sorry again. And feel free about what you do, but is that actually what is needed in this particular case in my work for society, or this is something more like a divertimento, something that you want to do for you? So I think that those are important qualities, and try to find the money to do it, because you will need that too.
Well, I think it depends if you're going through a very academic career versus what I do, which is more, project-based and scientific, but I'm not pursuing, a PhD or a professorship position. So I think it really varies. And I don't know, I think just having resilience helps a lot, and to realize that what you're doing may not at times feel like the most exciting thing, but it's leading to some place that is exciting and some place that is impactful. So 3 qualities, yeah, resilience is like one of the biggest ones, but yeah, definitely passion and having a group, I think, as well, that you work closely with and who is inspiring and supportive of you is very helpful.
Yes, and patience along the way. Right?
Yeah, a lot of things.
Yeah. Well, yeah, that feels like a good sort of wrapping up point here. And I'll just make a few closing remarks. Besides just a huge thank you to both of you for sharing your experience. And I know that the participants really learned a lot, as I did. So that's just about all the time we have left for this session. It's been a fascinating discussion. Thanks so much again to our panelists, and thank you to all of you for giving us your valuable time today, for joining this discussion, and for your thought-provoking questions. So for more information about Lamont and our researchers, please check out our websites and our social media channels. You'll find a rich collection of virtual content for adults as well as kids, K through 12 learning experiences, to fascinating webcasts featuring leading voices on climate and sustainability issues. Now more than ever, your support makes an important difference to the work we do. So we welcome contributions, and thank you again. I really look forward to continuing to share information with you and about the Earth Institute's critically important work.